Hi, this is Dr. K. Rajendra Prasad. I am working as professor and head for the Department of CSE Cyber Security at Institute of Aeronautical Engineering, Hyderabad. Today my topic is in the comparative design from regular expression to finite automata. So we have to discuss in the earlier classes. What is the idea of a regular expression and how can you convert the regular expression to finite automata? But another finite automata we have discussed some of the two options NFA and DFA. Here we have discussed already regular expression to NFA. Now we have the discussions about DFA also. Means once the regular expression is converted to the NFA to DFA, that is very important. Because of already have to see the application of regular expression is describing the lexicon analyzer and other pattern processing software. So for implementing this particular kind of pattern processing software, we have to use mostly DFA only rather than using the NFA, because we have some specific reason for defining optimality. Means what is the optimal finite automata? Nothing but definitely we assure that DFA is more optimal than NFA, because of NFA sometimes allows without symbol also you can reach the output states. That is called as with a null transition also you are reaching the output state, and sometimes using the same symbol we have to reaching the one state or more than one states also. So this is the idea of NFA. So we have the ambiguity for reaching of output states using the same symbol in the NFA, but that kind of ambiguity is totally resolved in the DFA. That naturally is called as a deterministic finite automata. Here today our discussion is regular expression to NFA. We have the idea, but and we also convert NFA to DFA. That is very important in the compiler design. According to the construction of the compiler design, so what is the most important prerequisite information is finite automatas. But we have initially the available things are regular languages only. The regular languages that can be described by the regular expression means language things that are described by the regular expressions. Then regular expression to finite automata is also very important. So we have discussed in last two classes what is the regular expression to NFA. In today's class, we have discussed the conversion is NFA to DFA also. We see in the construction of DFA, deterministic finite automata, one concept is very important, finding a subset construction. Means we have to see, suppose the total number of states are 2 only, so we have to get in the how many number of different subsets, nothing but 2 power q. So means the subset construction, so the subset value that should be belongs to 2 power q, any one of the subset that can be obtained from, what do you mean of 2 power q is? It is a power set of capital Q. Q nothing but set of states. So in the process of NFA to DFA, we have to find the subset construction, nothing but the subset is available, the particular subset is available when nothing but from the derived power set values of capital Q only. That we have to see. And the conversion of NFA to DFA takes more than the active simulation of DFA. Of course, suppose available machine is NFA only, but you need to convert the DFA. That case, we use this concept. Generally, we are recommending a direct simulation, a direct construction of the deterministic finite automata. So we have to see what is the process of constructing DFA via regular expression and NFA. So generally, the given thing is regular language things that can be described by one simple expression, that is called as a regular expression. And once you know regular expression, so finding directly DFA is not possible. That's why you take the help from the one of the finite automata concept, that is NFA So you convert to the NFA. Once you know the NFA, then you can find the DFA. Some are asking the question is why not you convert directly regular expression to DFA? It is also possible. The direct simulation is also possible. Suppose you want to go for via NFA and then DFA, it is also possible. But the answers are not same. The diagrams are not same. It may be different because of the DFA that can be constructed from the NFA with the idea of a subset of construction. But direct simulation, you cannot use the subset of some construction. So the DFA diagrams may be different. Maybe for the conversion from NFA to DFA, there is a different, and direct simulation of DFA it is also different. So we see what is the general idea of NFA to DFA conversion. The general idea behind the subset construction is that each state of constructed NFA that can be derived from the set of available states of the NFA diagram. Means, suppose we have taken the one example is Q naught is the one of the starting state. So we have defined totally for two transition labels. The labels are like this: small a and small b. So the NFA, as per the characteristic of NFA, it may reach to one state via null transition, or it may reach to more than one states using the same transition symbol. That case, suppose I am taking the example is Q1 comma Q2. So how many you are defining? Number of reaching states two, more than one. It is a characteristic of NFA. So we have to see that Q naught using A, we are getting total for how many states are Q1 comma Q2. In the case of equivalent to DFA, we have to find this subset construction. We can make use of this subset construction. What is subset is Q1 and Q2. But first we have defining Q naught. In the DFA, we must use the I think the set the particular state that can be represented by the some square symbols. The squares you define the Q naught, and you must define what the state corresponding state is. You called as single state. The name is Q1 Q2. So it means so we have to see the case is from the set of states of NFA, you are getting the corresponding state of DFA is Q1 comma Q2 like that. So here you are taking the next case is you find for this set of states of NFA, you are assuming one state of DFA. Here I am taking Q1 and Q2, Q1 and Q2. So we have to find what are the values for under the columns of A and B is. That case, apply the process for this subset of states or subset of construction. So we can make use of union symbol like delta, for example, is the state you are assuming Q1, Q2. Compound symbol is assuming A. That can be derived using the way subset of constructions like this. First, you can find the delta of Q1 comma A union delta of Q2 comma A. Or we can define different notations. Delta dash of Q1 comma Q2 comma A. Delta dash nothing but it is a transition function of DFA. Delta nothing but it is a transition function of NFA. So we have to check the cases we can apply for this subset of construction. So in this subset you are getting two different states Q1 and Q2. You must solve using the symbol transition symbol is A individually. Then you can apply you make a union of these two results. Delta of Q1 comma A union delta of Q2 comma A. So we have, suppose for example here we have the result is Q2 union Q3. So finally you can write here Q2 comma Q3. It is a brief idea of subset of construction. Subset construction. The general idea of NFA and DFA conversion, it make use of set of NFA states for defining the single state of DFA under any particular input symbol. The symbol it may be for A, B or any other symbol. So that's why you should generalize what the basic idea is. Suppose I am taking the input is A1, A2, so on n different input symbols you are taking. That case DFA we have to define DFA state that can be defined from the NFA. So what are the reachable states? The reachable states may be more than one. Using that is a subset. For this subset you have to how can you construct using the making the results. The results it can be applied by making a union. then the entire result you have considered one single state of DFA. So this is a discussion. This is a main discussion in the conversion of NFA to DFA. So here the same general idea syntactically I can represent how can you convert the NFA to DFA. As per the definition of finite automata, you must follow the 5-tuple syntax, set of states, input alphabet sigma, delta is the transition function, initial state is Q naught, and final state is the capital F. We also be defining like this. NFA and DFA also 5-tuple syntax. What are the 5-tuple syntax values? Qn, nothing but set of states of the particular NFA that can be described by the capital N only. Sigma is common for both cases. NFA and DFA is sigma is common, and delta n is a transition function of NFA. Delta D is a transition function of DFA. Q naught is the initial state of NFA. In the DFA also initial state is same, but the notation is different. You can make use of notation, the square brackets, in the DFA case, but in the NFA case, you can make use of simply Q naught. And set of final states in the NFA, Fn nothing but set of final states of NFA diagram, Fd nothing but set of final states of capital D. So you have to convert NFA, the given NFA N to the DFA diagram D. Means you try to convert NFA mission into DFA diagram D. It is the idea. Here, what are the common things? What are the where you are getting the set of subsets? Okay, QD in the DFA, the state that can be obtained, the subset values of Qn, the subset values of Qn. This side is called as subset construction. So QD is the set of states of Qn. That is, these set of states are obtained from the Qn. This idea is called as a subset construction. And QD is the power set of Qn. Yes, you make sure that what are the values for the power set for the given set of states of Q in the NFA you are getting. You are defining power set of the QD is nothing but power set of Qn. Note that, so what are the basic ideas? Suppose n number of states you are getting in the NFA diagram. So what are the states in the QD? At most, I am saying at most is 2 power n states. 2 power n states, because it is a basic idea of power set. Suppose you are taking the example is 3 number of states, Q0, Q1, Q2. So what are the, I think, states in the DFA? Maximum you are getting how many number of states? 2 power 3, that is 8. I am showing the states are, it may be empty, it may be Q1, like a single states individually, and a combination of states you are assuming Q0 Q1, Q0 Q3, so and so last combination is Q0 Q1 Q2. Total you are getting how many number of states, sir? 8 number of states. So that's why this final statement in the conversion is so in the conversion the NFA having how many number of states, sir? N number of states, sir. But in the DFA you are having how many number of states, sir? 2 power n number of states. 2 power n number of states. So where you getting the possibility for more number of states, sir? In the DFA. It is only for the case is the NFA to DFA conversion, not for the direct simulation of DFA. Direct simulation of DFA, it may be have the fewer number of states compared to this conversion. In the conversion, I think you may not sure to get the optimal DFA diagram, but in the direct simulation of DFA, it may be sure for getting the optimal diagram of DFA. You observe that point. So this idea is the conversion from NFA to DFA. Prior to that, we have the regular expression for one particular regular language. The final question is regular expression to finite automata, but regular expression to NFA to DFA. This we are going to the today classes. So finally, FD is a set of subsets of subset states, capital S of Qn. So we have to check it. How you obtain the resulting states of the DFA diagram is already shown the example by you have to find one particular state on symbol. Suppose there is some subset in the NFA Q1 and Q2. User symbol is A. How can you apply is in the previous as per the previous discussion is delta of Q1 comma A union delta of Q2 comma A. Means here we are assuming small p is a subset of states. So this subset of states where it is in the NFA. It is in the NFA. So for this you take each and the individual states. Suppose the subset of states are like this. Example is Q0, Q1 and Q2. These are subset of states. Comma and symbol is suppose you assume the A. So how can you get in the resulting state in the DFA diagram is delta D is a DFA diagram. Delta N is a NFA cases. So this is equal to you applying union. You are applying a union. What the P is? It may have the three states Q0, Q1, Q2. You take each and the each individual states. So it may be defined. S is this total value. P is nothing but any one of the value. First time is you assume the P equal to Q0. Next you are taking in next iteration is P equal to Q1. Next case is P equal to Q2. So like that you are assuming. So what happens is using this formula you apply the union. This is a union, no? This operator is union. Yes. So first is you have to find the delta n of n nothing but the notation is transition function. You find the transition function result in the NFA diagram. P is you are taking this example is Q0 and then you go for the A. Then you go for the A because you apply as per the formula is the union. Next is the delta n of another one is next state is Q1 comma A union delta of n of Q2 comma A. So finally you find the results that becomes the state of DFA. This is the state of DFA. So this I think only one formula I am recommending. So for the idea is the conversion of NFA to DFA using what approach is subset construction. So let us we have to see one good example regarding to the subset construction itself. So the general idea of NFA to DFA conversion. I am giving the one particular example. So for this, you need very important thing is the transition function delta n. Delta n is nothing but because of it is using the same symbol, you are reaching on two different states, no Q0 and Q1. Ensure that this is the NFA diagram. That's why you have to find the what kind of table is a NFA transition table. So at most totally how many different symbols are? How many distinct symbols in the diagram is zeros and ones. Okay, on the transitions, the symbols are only for 0 and 1. So here what are the states? Q0, Q1 and Q2. These are the states. So you have to see what are the results are. So Q0 using 0, you have checked only for two possibilities. First you have to put some tick mark on possibility reaching to same state Q0. So another 0 case is this another 0 case, it reaching to Q1. So you have to check it using Q0 comma 0, you have to get it not for a single state. Here we get in the two states. It is some subset idea. This is for the some subset idea. And the Q01 is only you are reaching the one state that is called as same state. It is self loop, no? One is self loop. It goes to again the same state is Q0. And Q1 comma 0 not there. Only Q1 comma 1 is there. Q1 comma 0 is empty. Fine. So next one is Q1 comma 1 is it is available. It goes to what the result state is Q2. Okay, and Q2 is there is no transitions of 0 and 1. So that's why is also pi. So this table is called as what the table is delta n nothing but the NFA. This table is transition table for NFA diagram. So you must convert into the DFA. Okay, here I am taking the DFA diagram. It is called as per our formula We are discussed now as per our formula. This is the delta D, or that is the tangent table of the DFA diagram. Tangent table of the DFA diagram. So we have to check it here. The symbols are same. You take this idea is this all states that can be described in the DFA for differentiating the the states that purpose in DFA. You must use some square notation. You should take is also starting state. The starting state. You take Q naught. You take the Q naught. So Q naught using 0. It goes to what the resulting state is Q naught under Q1. Q naught under Q1. Q naught using 1 is the Q naught. So up to this is same. Next, so what are the I think results that is subset or it may be single state. To got it, you assume this for the new state here. You must write. Okay, you don't refer remaining other things. You take the reference starting is same because you must start here also Q naught itself only. So Q naught using 0 is defined. Q naught is 1 is defined. So Q naught comma 0 it goes to Q naught Q1. Okay. So thus it goes to where Q naught Q1. You write here Q naught Q1. So as per our knowledge, Q naught Q1 is a subset using 0. So what you take? You apply the union. Q naught comma 0 union. There's a delta. Delta of Q naught comma 0. I am writing here delta of Q naught comma 0 union. Delta of Q1 comma 0. Q1 comma 0. Means Q1 comma 0 is Q naught Q1. Q naught comma 0 is Q naught Q1. Q1 comma 0 is pi. So you make union of these two values. You're getting again the same thing. Q naught Q1. Similarly, here Q naught Q1, okay, Q naught Q1 using 1. You apply the union. Q naught union Q2. Q naught union Q2. You're getting new state is Q naught Q2. This way, we have to construct the DFA tangent table. And again, this is completed. Next one is Q naught. Q naught is already it is completed. Q naught Q1 is also completed. What is the state here? Q naught Q2 is a new subset. Okay, you find always a new subset only. Q naught Q2. So what is the Q naught Q2 is? You make it around here Q naught Q2. All the results, this one result union this. Q naught Q1 union pi. Or getting the result is same thing. Q naught Q1. And one more is Q naught union pi is a Q naught. I think everything is completed. So this is a complete DFA tangent table. Once you know the DFA tangent table, so from that you have to construct the diagram. So what is the starting state here? Also we are using the Q naught is the starting state. Q naught is the starting state. Yes. And Q naught using 0. It goes to what the state is? Q naught Q1. Is it right? And Q naught using 1 is only for Q1. Just check the table. Okay. Just Q naught Q1 using 0. Self loop. Q naught Q1 using 1. New state. Q naught Q2. Okay. Q naught Q2 is a 1. And Q naught Q2 using 0. Again goes to Q naught Q1. Q naught Q2 using 1 goes to Q naught. So like that we have to construct the DFA diagram also. You check the sequences. NFA diagram to NFA tangent table, NFA tangent table to DFA tangent table, DFA tangent table to DFA diagram. After that, finding the final states of DFA is very important. Here, what is the final state? Double circle is defined here. Qt is the final state. But in our table, where is the Qt is? Qt is here only. So Q2 already it is not there. Q2 combination with Q0 is there. So now Q0 to Q2 is totally becomes one single state. You are taking it becomes totally for one single state Q0 to Q2. So now you put the double cycle for where Q0 to Q2. So this is the idea for conversion of NFA to DFA. So sometimes you are getting the question is direct simulation of DFA also. At that time, you need not apply this conversion concept. Directly how to construct the DFA diagram also. But as per the our topic is regular expression to finite automata. That's why I'm explaining regular expression to NFA and one more finite automata is DFA also there, deterministic nature. It's very important. That's why I'm giving that idea also in today's class NFA to DFA. So this is about today discussion, and similarly you can also solve a totally given what kind of table is delta n. NFA tangent table. From that you have to construct the DFA tangent table. From that you have to construct the DFA diagram. DFA diagram. This is one of the another example. Same. This is also another example. Same. This is also delta n is given. We must solve the under DFA tangent table. We must solve the another also DFA diagram. The same questions. Okay. Already I had shown no the same questions here also. Is also I think convert a DFA to NFA. So this is the delta N and you convert into delta D. This is the delta N. This is totally for delta N. Okay. Convert to delta D and then you have to find the DFA diagram also. So this is about the today discussion. With this, the idea of regular expression to DFA is completed. Okay. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.